Hello again, Algebra 2 students. We're back in our complex numbers syllabus and we're going to do Tier 1, Lesson 2a. This is Intro to Complex Numbers and Imaginary Numbers. So here we are. Recall in Unit 4 that anytime we use the quadratic formula, we found that if there was a negative under the radical, we always said there were no real solutions, which is real important. But with a set of complex numbers, we can actually come up with an imaginary number. Now we'll introduce you to the complex set of numbers. Within the complex set of numbers, we have the real numbers, which are the numbers that you guys are used to dealing with, which run from negative infinity all the way to positive infinity. And then you also have the imaginary numbers. And an imaginary number is written in the form here, a plus bi, where a and b are real numbers and b is never equal to 0. The imaginary unit I is the complex number whose square is negative 1. So what that means is I squared, which is the imaginary unit, is equal to negative 1. So therefore, as you can see here, the square root of negative 1 is equal to I. Shifting gears a little bit here after we took those notes, I'm going to remind you guys back from Unit 4 and also from skills from Algebra 1 how to break apart radicals. So if you have two factors under a radical like a and b, you can break it apart and have the square root of a times the square root of b. So here, let's do some prime factorization, and we got 4 and 5, and we got 2 and 2. And if you remember from Unit 4, we were looking for pairs. So I have a pair right here with the 2 and the 2, so I can break this apart into the prime factorization here of 2 squared, the square root of 2 squared, times the square root of 5. Well, the square and the square root cancel out, so that just gives me 2 times the square root of 5, which we can also just write as 2 square root of 5. Here with the 45, again, I want to do prime factorization. Well, I know that 9 and 5 give me 45, and then I know that I got 3 and 3. Well, here I am again looking for pairs. Here's my 3 and 3, that's my pair. So I know that this will break into 3 squared square root times square root of 5, which again, the square root and the square cancel. So I get 3 square root of 5. On 32, I'm going to break into 2 and 16. And then I'm going to break 16 into 2 and 8. And then I'm going to break 8 into 2 and 4. And then I'm going to break 4 into 2 and 2. And now I'm going to circle my pairs. I have 1, 2, 3, 4. I have 4 2's, but I have one odd 2 that's going to stay inside. So I'm going to have 2 squared square root times 2 squared times the square root of 2. Because that's the one that, this one right here is the one that doesn't have its partner. Well, these simplify into 2 times 2 times the square root of 2, which gives me 4 square root of 2.